Okay, so here we are on the last lesson of Module 1, and this is where we are going to calculate mean and standard deviation. You guys have already calculated mean a little bit, but now we need to talk about standard deviation. Just like when we had median, we use the 5-number summary and the quartiles more particularly to kind of measure that spread when we have a median. We look at the middle 50% of the data for skewed distributions, and that's what we did with box plots and the inner quartile range, IQR. But when we talk about mean, we don't talk about the IQR. We actually talk about standard deviation. Standard deviation, if I were to say it in layman's terms, I would say that it's how much on average you're deviating from your mean. So it's like the average distance from your mean, and that's how we're going to calculate it. I have a data set here that you guys can practice with. If I had you guys in class or in Zoom today, then I would be doing this one with you. But I do have notes here as well. So to talk about some key points briefly before I move on to my example, so you can actually see it in action, standard deviation goes hand in hand with mean. So for median, we will use IQR and box plots like we did the 5-number summary on Friday. But for mean, we use standard deviation. Median IQR, mean standard deviation. So the way that we calculate standard deviation is with this formula right here. And you're going to see this formula again. But essentially what you're doing is you are taking the sum of the distances. So when we measure distance, it's always like x minus your mean. That means how far away that one value is from your mean. We square it, because that's what we do when, like, think about the distance formula. We square it to make it positive because distances can't be negative. So we square it, and then ultimately at the end, we're going to end up square rooting to undo that. So that's where you see this square root right here. We're going to undo the square. So that is the formula. We do divide just like the mean, right? With the mean, we divide by the number of terms. Here we divide by what we call n minus 1. So it's like dividing by the number of terms, but you take one of those terms out. In a nutshell, that's called degrees of freedom. And just to kind of summarize what that means, we take out one value because now you're dividing by less. So it's actually like erring on the safe side when we look at data. So that's the easiest way to think of degrees of freedom. Sometimes you'll see this a couple other times as well, where we do n minus 1 instead of dividing by n, just to allow a little bit more error so that way when I report it as a statistician, I'm allowing for some error in my in there. Okay, I go through an example here that I'll let you guys look through on metabolic rates. When you have this, I calculate the mean first, and then I have standard deviation. So like on average, how far away from your values are the mean? And then I calculate that. Like I calculate this one right here, 1792. I subtract the mean. That's how far. It's 192 away from the mean. I square that number to make it positive, and then at the end, we're going to go through and square root all of that. I add them all up. This right here is a table that helps organize what I'm going to do in our example. I'm not going to use the table in our example, but I'm going to show you an example in just a minute. You'll notice that I have 7 values in here, so I'm actually only going to divide by 6 instead, and this gave me a standard deviation of 189. So you guys can go through that example and really see mathematically how we get it. This is a quick like closure. Median and IQR, that's how we're gonna, that's center and spread in a skewed distribution. And in a symmetric distribution, we're gonna use mean and standard deviation. Okay, I'm gonna go ahead and leave this video now and pop over and see an example of this. It's really important to watch that example in the next video.